Okay, this is a lap joint. This is 1/8 of an inch thick mild steel lap joint. See, that's a lap joint. I'm going to weld this in the vertical position like this. We'll go across it like that, and I'm going to be using an E6013 3/32 size arc welding rod. E6013 3/32 size Hobart arc welding rod with 61 or 62 amps DC electrode positive current. Now, when you put these two pieces of steel like this together, it keeps them cooler. Like if you're welding on one piece of steel like this on top, it'll get this piece hot fast, but if you put a piece under it like this, it'll kind of keep a top piece of steel cooler. Or if you attach it to it like this, it keeps it cooler, because the heat will move out of this piece of steel into this piece of steel, and all the heat doesn't gather up in this one piece of steel and make it melt faster. So when you weld this, like you might have to bump up the amps a little bit, you know, 3, 4, 5 more amps, a few more amps to make it penetrate enough when you're putting two pieces of steel together like that. But I'm using 60, 61, 62 amps DC electrode positive. I'm going to see what that's going to do. Let me make sure the camera picks this up. I'm going to tack this together first. This is E6013 3/32 size arc welding rod. That's a Hobart welding rod. It's made by Hobart. Hobart that makes welding tools. Huh. So I'm going to have to turn up the amps a little bit more. 70 amps. It didn't penetrate. Well, let's see. Maybe 65 amps, because it got this plate warm. So what I'm gonna do, I'm gonna turn this over, because I've done put a piece of weld streak right there, a piece of weld. I've done put a blob of steel. I've done put a piece of steel stuck on that now. So let's see. Well, see, that was a cold start. That's why. Okay, let me show you something a minute. Let me show you something a minute. That was a cold start. This metal was cold when I started. So what happened was, it didn't penetrate into both pieces because it was cold. See, it just run down on it, but it didn't penetrate because both pieces of metal were cold. And sometimes when it's cold outside, you got to get this metal heated up to make the rod penetrate it. Okay, the welding machine that I'm using is a Harbor Freight Tools 80 amp DC current inverter arc welder, and the Harbor Freight Tools welder I'm using does not have a control where you can control the arc force, so it don't have that control. You can't, it doesn't have a voltage control either, so you can't really do anything. You can't control how hot the arc is unless you turn the amps up. There is no voltage control or arc force control on this Harbor Freight Tools 80 amp inverter welder. So sometimes if you're using a welding machine like this, if you're using a Harbor Freight welding machine that doesn't have an arc force control and all that, you might have to take a blowtorch and heat this metal up, so when you strike you know, an arc to it, it'll immediately start penetrating, because it has to be so warm. That's what happens when the metal is cold. So I have an idea now that it's not going to do that when I start welding on it again. And then I've turned the amps up 5 more. So this is 1/8 of an inch thick mild steel. All right, so I'm gonna tack this again. I don't have a blowtorch right now. You can do it with a propane blowtorch. A lot of people that weld do it with an oxygen and acetylene torch. All right, so I'm gonna tack this together right here on the end. Using 65 amps DC electrode current, E6013 size 3/32 arc welding rod. Get that bare metal on there. Let's see. I think that time, there's some fusion. So now it's tacked together, okay? Let me complete this. Okay, so 5 more amps and a little bit of warm metal seems to have did it. So let me the weld streak on the most part went smooth. So here, well, so here, warmer metal, and 5 more amps seems to have made a fairly decent penetration using an E6013 3/32 size Hobart welding rod at about 65 amps, going in the horizontal position, welding a lap joint of 1/8 of an inch thick mild steel. So when I first started on it over here and made that heated the metal up. You can see there's penetrated right there, it's fused. That is ugly, it's not very pretty, but it is fused. And that's the important thing, it's fused. It's penetrated together. You see where that's kind of like melted in right there? See that? Wait a minute, let me get something. So you see where it's penetrated in? That's what you want. You want to make sure it's penetrated. You want it to have a tiny bit of undercut.